Hi, welcome to my course about getting started with Web3 development with SvelteKit. This is an introductory course to help you learn about the many moving parts required to start building a full-stack decentralized application with any EVM-compatible blockchain. In fact, you can take all of your learnings of this course and move into any other blockchain as far as compatible with Ethereum. During the course, you learn how to write a smart contract using Solidity language, how to test a smart contract using just JavaScript through the Waffle framework, how to communicate and interact with the smart contract using ethers.js on top of a SvelteKit application. And finally, how to deploy your smart contract to make it public and accessible to anyone. This course is focused on JavaScript developers that just want to dive into the Web3 train. By the end of the course, you'll be able to take your new skills to create any smart contract application you want, along with implementing a decentralized application with any JavaScript framework. This course uses SvelteKit because of the low and quick learning curve, but you can use any other framework. You'll notice in the next lessons that almost 99% of the JavaScript code you'll write is just plain JavaScript. This set of technologies will help you get on board of the Web3 hype and also help you on your next professional endeavor or Web3 related project. I hope you'll enjoy this course, and definitely let me know how you like it, or if you have any question, just find me on Twitter or in my personal site as matiashernandez.dev. Please enjoy. Let's start this project with a little bit of setup. The first thing that you'll need to set up and configure is the SvelteKit application. This will be the entire scaffold of your project. To start, let's just run this tiny script in your console. Tipjar is the name of the folder. Let's answer these questions with proceed and choose skeleton project. You won't use TypeScript for this course, but you will want to add ESLint and prettier. Next, you'll want to add some styling tools. In this case, you'll use Tailwind. To add Tailwind to the mix, you'll use an adder. This is a utility package that you can run directly in your terminal. Let's copy this little piece of code in the console. This will configure everything you need to run Tailwind into your SvelteKit application. You'll need to wait for the dependencies to be installed. Now, let's install the development environment of choice for this course. This is Hardhat. It will set up an Ethereum development environment, allowing you to run a local blockchain. Go ahead and copy this little snippet to install the requirements. This will install Ethers, a library to communicate with the smart contract, Hardhat, and some dependencies that will be used to test your smart contract. After the installation process is done, it's time to set up the environment. Just run npx hardhat and answer the questions by creating an empty hardhat config file. And then you're done. Now, you need to create a few folders for this configuration to work. Let's start by creating a script folder. Let's also create a contracts folder under src/contracts. Here is where the contract will live. And lastly, the test folder to store your tests. Now, let's open your code editor and modify the Hardhat config file. Open the file first. Then, you'll need to import the Waffle framework. So, require the Hardhat Waffle package. This allows the testing environment to be loaded with Hardhat. Let's bump the Solidity version to at least 0.8.4. And now, it's time to add some configurations to it. The first configuration is to add the paths to allow Hardhat to find certain content. So let's write paths and set up the artifacts. This is where the artifacts will be stored after the smart contract compilation. The sources where the contracts will be stored can be found in src/contracts. And finally, let's set up the network's configuration. This will allow Hardhat to connect to a local chain network. You'll set the chain ID to 1337. The last step to make all of this configuration work is to add an empty package.json file. This is because SvelteKit is an ES module package, and you need to make CommonJS play well with it. It's time to start writing Solidity. First, let's create a file for the smart contract. Name it as tipjar.sol. This is a Solidity file. The first thing you need to declare is the SPDX license identifier, and then choose any license. I chose GPL 3.0. Then, let's set the Solidity version using the pragma keyword. And now, import a utility contract from Hardhat named console.sol. This contract allows you to print to the standard output using console.log, same as JavaScript. Now, let's create the contract by writing the contract keyword and the name of the contract. You'll notice that this is very similar to a class. Next, you'll create a public variable as integer named total tips. Then, a fundamental function, which is the constructor. This is an object-oriented programming language. So you have constructors, and the contract is like the class. So let's write the constructor, which will not accept any arguments. The only thing this constructor will do is console log that this is a smart contract. Now, let's write a little test for this. Testing smart contracts is one of the most important things you can do, since the nature of blockchain is immutable, meaning that the smart contract, after being deployed, cannot be changed. So let's test this. Let's create a file under the test folder named tipjar.js. Let's require the expect library from Chai and the ethers library from Hardhat. This library will help you to interact with the smart contract. So let's describe this as the tipjar contract and write the first scenario for that. You will store the contract variable globally and then write the description as follows. Should deploy the contract and return 0 as total tips. This is an asynchronous function. The first step is to create a contract factory. This is done by using the ethers contract factory function, where you just pass the name of the contract that you want to deploy. In this case, tipjar is the name. Then, utilizing the contract factory, you create a contract instance. So, await contract factory.deploy, and then we'll wait for the contract to be deployed. Now the contract is deployed. You can expect these asynchronous functions. So, write contract.totalTips to be equal to 0. This is what you want. If you're wondering where total tips came from, you created a public variable earlier. Solidity will create a public getter to every public variable you make. This means it will create a public function named the same as your public variable. This function will return the value of that variable. In this case, it will be an unsigned integer. Now it's time to run this test. Let's see what you have. Open your terminal. Be sure to cd into the tipjar folder where the project is. And let's run Hardhat test. As you can see, this fails because of some weirdness with how ES modules and CommonJS work together. So what you need to do is to rename the Hardhat configuration file to be a CommonJS file. And then create some npm scripts inside your package.json file. To run Hardhat with this new configuration, let's make the first script to use it with the new configuration file. Then, let's create one script to compile the contracts using Hardhat compile. And you'll do the same thing for running the tests. And finally, a command that you'll use in the following lessons: Hardhat deploy. This will just run Hardhat with a script named deploy to the local network. With this in place, it's time to run the test again. So in your terminal, run npm run hardhat test. The test will start running, compile the smart contract for you, and then check if it's passing or not. You have a green, so your smart contract is running flawlessly. For this lesson, you created your first contract, you made a public variable and a constructor, and you wrote your first JavaScript test using Hardhat as the development environment and ethers.js.